guide of fun technology plus in some processing technology.
Okay, you can start now. Your lab.
Hello.
Yes.
Welcome everyone. Thanks for joining us for today's webinar series. Myself, Rishil Bhagat, working as an assistant professor in Parul Institute of Engineering and Technology, Diploma Studies at Parul University. Today we are presenting webinar on the topic of application of IoT session, which will be delivered by Mr. Treyesh Shah sir. He has completed his Master of Technology MTech in Embedded System from Nirma University. Sir is working as a software engineer and freelance consultant. He has also delivered many expert talks and also delivered many webinar series. So without wasting much time, I invite Shreyas sir to share their valuable thoughts for our audience. Thank you, sir. Sir, you can start. Yeah.
Good morning, everyone. First of all, thank you, Rishil sir and Parul University for providing me this wonderful opportunity. But as Rishil sir told about, like today's topic is Internet of Things and its application. So we will just briefly directly go into the deep dive of the IoT, that is Internet of Things, and its applications. I'll just share my screen. Yep. So hi everyone, and now as we have discussed, today's topic is Internet of Things and its application. So let me just give a brief idea about today's agenda, or the in this hour what we will talk about, and what you, after this hour what you will be able to understand about IoT or Internet of Things. So initially, like, I will answer your three questions about IoT, that is what, where and how. That is, what is IoT, where can it be used, and how it works. Basically, these three are the major important questions for any of the technology, not only IoT. These three are very difficult to understand. First, these three questions are understood easily, then any ecosystem or any product or any uh, real-time use case scenario or problem can be solved using respective technology. So there will be, like, then we will be have a brief introduction of its stack or the architecture that helps you to analyze and work on deploying or developing an application into IoT ecosystem. Then we will go through brief of IoT applications, that is in different verticals, like which we basically use in a daily agenda. So that is like IoT in our daily use or daily agenda. As well, we'll cover up one or two or few real-time use case scenario or real-time problems that can be answered or that can be used solved using the IoT technology. So the objective of this are, for me, the goal for me is like to provide you the direction to brainstorm yourself and develop an innovative ideas to the solution using IoT to nullify the real-time problems or real-time difficulties in our day-to-day life. Also, this will be attained by having a deep dive into IoT with its architecture, and then we will discuss about different applications in different verticals. Like, if in a day-to-day life, if you see, that is like smart home or a home automation, then these days wearables, many more applications are there, many more verticals are there. We will discuss in further slides. Okay, so now Internet of Things. First, I would like to just tell, like, at the first glance or the first depict of this picture, what it says and what it is. Like, at a first glance of you of this picture, you can say, we can say, like, it is like connected everything with a human body, or a human being. Like I can just show, see, this can be a human brain, so we can understand this. So okay, this is the human, and these are the multiple devices which are connected to humans, and all devices are connected to each other. Either it's a PC or your home based devices or gadgets like washing machine, fridge, microwave, the audio video systems, this VR. Then it's connected to even car, your home based or office based cameras, air conditioners, printers, the PC, home systems. These all things are connected to internet via um, like using multiple technologies into the IoT or multiple protocols or frameworks. And this all is like connected and driven by, can be driven by a single human being or a people using the mobile phone or any applications. So using this picture, we have already defined what IoT is, but now moving forward, we can say like it is using this picture, we can say that internet of things, what things are. I told like these are the connected things or connected devices, and what things are. Basically things are nothing but the normal electronic gadgets or devices which with an added feature of connectivity as well as a smartness. So if a normal device gets connected, get a interface of connectivity to internet, as well as has some abilities of like smartness, like automating the features or ease or seamless use of specific gadget for the human being, that turns into things. So let's see the proper or the phrased or paraphrased definition of internet of things. So the basic define or definition of IoT is like IoT is a network of physical objects, that is physical things, which can be vehicle, appliance, or any devices that are embedded with sensors and software and network connectivity, so they can collect and exchange and act on the data oftenly without any human intervention. Like if any device is there, and our normal, like in a day-to-day life, we what we use regularly is like, let's say air conditioner or washing machine or fridge. These are the things which we use in our day-to-day life, and if we provide a small, let's say some embedded board or embedded device which we just plug it into that device, and that can be that can have multiple features like sensors or network connectivity, and which can be converted, which is like add-on smartness to the normal device, and that is totally a smart device, and which can be called as thing. And for us it's like things that can be connected to us via internet. So it is like IoT enables the devices to collect and exchange the data in a very seamless manner, like ease in using the devices or ease in exchanging the devices without any time delay or timestamp. Latency is less, so it's very fast, very responsiveness. Then it comes like it allows things that have ability to sense and control, that is we use sensors and actuators in the existing gadget or existing thing. And this is a ecosystem which can be controlled remotely over existing network infra, because we don't have to be specific with the usage of internet, like what internet is required. The internet which is required is into our day-to-day life, which we are using since 1990s or 2000s. Just we need to add some ability or some smartness to this devices, normal devices, which can be connected to internet, and just get connected in a seamless manner with us, which can be controlled or sensed remotely. And it's like it has a improved efficiency with integratability and scalability. That is, what can it be like? Integratability means if any of the device comes up, like let's say we are going to the shop or to the showroom and buying a washing machine, but it must have an ability to get connected with our inbuilt home ecosystem or inbuilt our applications. So that is integrated. It can be integrated to our existing network or existing application. And scalability, that is like it is not limited to a number of devices. Like let's say if one internet connectivity is there, which can be used for only 5 devices or 7 devices, it's like multiple millions of devices can be connected over single internet connection. So that's the benefit in a home ecosystem. In a day-to-day life, we don't have to buy or have to take an interconnection for multiple devices, multiple connection. It's not like that. It's like existing system integrating or upgrading the devices as and when required. And scalability, that is we can add multiple devices, any number of devices can be added. We can control using the existing network or using the existing internet. We can control our car, control our parking system or surveillance system, our kitchen gadgets or bedroom or living room. Anything can be controlled, our TVs, anything can be controlled. That are the basic main features: integratability and scalability. Our these days, let's say wearables, smart watches, it's very widely used. Those are widely used. Normal watches are just going up, and smartwatches are bringing up again and again. These days, young youth, we are fitness freaks and we use smart variables. So what it is, it's not like that we have to change the mobile if we change the brand of the or the make of the smartwatch. It can be connected to any Android phone. It must have only two features, that is internet connectivity with the smartphone and wearable, and Bluetooth connectivity. That is, it can be connected. It can collect data, exchange data, or transfer data, anything. So these are the basic example, or these are the real time scenario for integratability and scalability. And one is like mobility, mobile. So what this mobility understands from the word is like mobile is what? Our smartphone. In a layman language, it's like mobile, we are roaming here and there. This device can be in at any location. So in this way, this scalability, integratability, and mobility, if these three things exist, we will discuss further in further slides. But if these three things are existing into our system or into our ecosystem or in any application, it is like uh, we have an end-to-end solution, or we have a full ability or the smartness added to the embedded device or the things. Moving forward, now let me actually tell you that IoT, this is the basically this is the paraphrase or Internet of Things. These are the three words which are basically very buzz these days. But is it like that we this IoT is discovered now? No, actually it's not discovered these days. This existence or the it has its presence since our grandparents, but the way of use, the way of interface was different. How we evolved the internet, use of internet from decades or eras to this present era. That is like internet of documents. So initially we had internet in 1990s or 2000s or 1990s 1980s, but where it was used, its use were different. So basically this evolution, this slide will resemble the same. Like it started with the documents, that is we were connected to, just an example, like we were connected internet with our laptops or PCs, the systems. Those days the big computers were there. These days many small microcomputers are there. Sorry. So these computers were connected in a network and can data transfer can be done. Later stage, we got connected it with like a commerce, that is commercial purpose, like the era where cyber cafe. If you guys remember, like earlier we used to go to cyber cafe because the internet connectivity was not available or not that much frequently used. in home to home basis or daily life. So there was an era internet of commerce. Then it comes internet of applications. It's like early 2000 phase, we can say, uh, nearly 2008 2007. After that, internet of applications, like multiple applications came, means were developed, web based or mobile applications, and can it where a software era was transitioning, and this transition started, and from which then it comes like internet of people. Now internet of applications and internet of people, this two combines the smartphone era, where the smartphone era started. It is like the awareness or the use of internet started very widely used, and the people were connected or are connected. Presently we are also connected to each and everyone via internet. Like just an example, if these days we have all have smartphones, if our parents want to track us, they can easily track. Our GPS location is on in our mobile, they can track just we need to share the location, or there are multiple features provided by Google that our location or our activities can be watched by the parents easily, or any guardian. So, and now it's like internet of things, that's like we are very fond of using it and connecting it to devices, that is IoT. Like we used to say, like, hey Alexa, hey Siri. These are the buzzwords, and these are the use cases. Like we tell devices to do this, to we want to drive the devices to act on upon any actions or act upon any use or any event. Okay, so now let's move ahead with other two questions which are still remaining, that is how and where. Now what is answered by me means I hope you would be able to easily have a brief idea or clarity what is internet of things or what is IoT. It is like not any bookish or bookish definition or anything that you have to grab it, like our history or civics uh, questions or civics theory. It's like a basic real-time use case. Just we need to uh, pick and plug and play activity, and we can easily do these things. So now, how this IoT works? So basically, there are four components for this IoT ecosystem. That is things, that is devices, which plays a major role for in this technology or in this ecosystem. Then comes up like controlling devices, and means we used to control devices with mobile application or web application. And then comes a global or a local network, that is these devices are connected to the controlling devices via internet or any other protocol, internet, then Zigbee or a Bluetooth or BLE, that is NB-IoT or any other protocol. So this requires global or a local network to get connected with each other, so that remote operations can be done, or uh, give and take of data can be done. Now we add one more component, is like cloud services, that is basically used for storing the data or analyzing the data, and rather human act on any event or activity, the data will act on the uh, activity or the driven anything driven by the things. So that is what cloud services is used. How means basically what where we use these things. It's like let me brief out, is like things. So things can be anything: PC, our connected cars or gadgets, or multimedia systems, or industry in civil construction side, or any manufacturing company, anything. So there can be a device, things can be any devices that can be connected to internet, and this can be remotely controlled or viewed. They can be they can send or receive a data like telemetry data, that is the event based data, that this is totally a digital data sending mechanism like zeros and ones, which we can't understand the language. But yes, we will see in the stack architecture how this machine language is converted into the human readable language, or how each layer defines different language, and each layer requires different languages to understand with each other. Then comes up is like controlling devices. So these are basically a smartphone or tablets, which are basically having applications to control or to use the end devices, that is things, via a global or a local network, which are also connected with cloud services. That is, it can store the data or it can analyze the data as and when we required. Like just not an IoT based example, but a simple example. If you want to check, you can also check someday, sometime, if you get to, if you want to know, or if you are eager to know. Like if you will check, go to Google Maps, and if you want to check whether which day, where you were, on which time, it will easily tell you. It has Google Maps has an like a feature that that a location 24 by 7 our location can be shared, as well as where I was before 4 years at this time on this day. If I may not be knowing, but Google Maps might be knowing. Maps can easily tell me. So that is data aggregation, cloud services usage. That is, it's provide the repository, and cloud services basically provides repository and access controls between things and its controller, that is controlling devices. It's the same what I uh, told regarding these two things. Then it comes like a global network and a local network. And now basically network is required for any devices, because we need to get connected to the things. So as this figure resembles, let me, as this figure resembles, I will change color. Yep. So what this tells, these are the different, let's say these images are to express or to provide your knowledge at local network. What does it mean? It is like connecting to the gateway, and this global network is like connecting to the globally to the human being via cloud services, that is clouds, as well as the application. So these are different use case scenarios. Again, like this is connected cars example. This can be a medical or healthcare based use case. Then home automation based or office based use case. This is industrialization, that is industry 4.0. We these days it's very quite buzz these days, industry 4.0, 4.0, 5.0. This is nothing but industrial uh, change or the transition of like deploying multiple things or multiple devices into heavy or high heavy duty machineries, and which can be operated, which are required to operate at 24 by 7 365 days without any human intervention. This can be done. So that is connected industry, connected internet of things. Then comes like electricity, and in that domain it's like smart meters, or using multiple technology, LoRa based technology or NB-IoT based technology. We can, or you deploy a smart meters or electricity. EV based cars these days are coming up. So I will discuss one of the scenario, if time permits, for this EV based cars also, how IoT gets connected with it. Okay, let's move forward. Now we will just check or see where this IoT can be used. Now we have covered two questions, that is what and how. Now let's move forward with where. So basically IoT things, that is any devices, can be used by anybody in any network that we discuss, in a local network or a global network. There is any network anywhere, any place that resembles the remote integratability scalability point in any time, any context. That is Internet of Things. We need just connectivity. Device needs connectivity. They don't need to sleep. We are human beings. We need 8 hours sleep at night. We are tired. Those are devices. Those are smart. Those devices have to show the smartness. They doesn't matter what data you are sending or what data they are picking up and sending. It's their They are at job. The devices have to do their job, just data transfer. So anytime they can, or the transfer can be done, or in any context, whatever data it may be, and any service or any industry. That is like in any industry or any verticals of our day-to-day life, in home, business, or transportation, logistics, anywhere this can be used. IoT can be used. So once again, just a brief: what, where, and how. What it's like: connected things with an embedded features like software, hardware, and smartness of connectivity. How it works: things gets connected with the control devices with an ability getting connected to cloud service as well as home and local network, a global network, so that the data can be stored in cloud, and uh, the devices or the things can be controlled via mobile phone or any controlling device using global or local network. And this, whatever events or actions happen, cloud will be storing, or cloud will be able to store. That is a the data is the next fuel. That is, we are saving the fuel of data. Now we have been talking like how, what, where. Now, since this era is booming up and on the IoT, this is a quite older data, but per person, means if I am the single person, earlier, like it's in 2000s, we were connected to 0.08 devices. Like, because as we discussed in evolution side, during 2000 2003, we were into this era maybe. So we were not, every home was not connected to internet. Everybody was not connected to internet. We were using small phones, GSM or CDMA based phones, and we, for any work, we have to go to cyber cafe. Like as in time passes, like 2010 2000, nearly 2000, smartphone era was just kicked in. There we were, each and every person were having smartphones. That is, they, and some of the devices, like using smartphone, we were connected to internet, we were connected to cloud storage, or some of the devices that you increased, gradual increase in connected devices per person was like approximately 2. And then later, right now, these days, it's in 2020 it was said it is 6.58, but this way, these days, it's like in a fingertips we can count. It's almost nearly 9 to 10 devices minimum. That is mobile phone. We are synced with our office laptops or house based systems. Then wearables. Then one of the 5 houses have Amazon Echo Dot or Alexa. We are connected to that. Then we have smart mobile, that is light bulbs, or we can say like surveillance systems that comes up into 5 6 devices. So it's like on fingertips we can easily count like how many devices we are connected. That is the real time data. So this is how it's the use of internet of things, or internet is getting increased these days. And now, let's move forward with the its stack or the its architecture. So, first, let's move forward with the, its stack. That is, the IoT ecosystem. So, IoT ecosystem is a where basically we will be able to understand how this system is getting. We just defined embedded device, hardware, software, and connected ability. But these three things, three words, basically means a lot for an embedded engineer or for our IoT engineer, because any device comes up with a big architecture, there is a stack. So I hope you would be knowing about the 7-layer OSI layer stack architecture, that is physical layer, MAC layer, network layer, transport layer, session layer, presentation layer, application layer. So in the same way, IoT has all these layers, but in a different manner. So basically it is divided into, from 7, it becomes into 4 layers. That is network layer or link layer, then internet layer, transport layer, and application layer. These are the 4 layers. Now these 4 layers are basically divided into one or two different verticals for getting connected to each layers. That is network or physical layer, that comprises of a physical device. That is, if we want to convert our normal plug into a smart plug, then we need some ability. That normal plug needs some ability, the use of some radio RF, that is required in build. So that is the physical layer. Now to control that RF, or to talk to the RF, we need multiple things like the exchange of data. Okay, how can it be done? We need the transport layer, that is the transmission of data. Then how we will transmit that data, it is again, then comes a picture, internet. Now how this, there are multiple billions of millions of devices, how can we connect to each device dedicatedly? So there is a provision of like IP based routing, that is IPv6 or IPv4 or 6LoWPAN. That is basically a ID based IPv6 based 6LoWPAN has basically a ID based communication. Each device has unique ID, that is 64 bits, and gets communicated with each other in the same way. So how, and then comes application layer. So application is like our IoT application, whatever application we want to make for a single device. If I have a normal bulb, I want to define a bulb as like multiple features, that is applications, on off, then dimming up, then person detection or moving. These are different applications which resides on application layer. So basically the net application layer, it has, each layer has different protocols to be used for their understanding as well as data transfer or data processing. We require these things. So let's just discuss like application layer. So it has, first of all, these protocols, that is data transfer, we can call data transfer protocols, CoAP, MQTT, AMQP, XMPP. There is these protocols are nothing but JSON based or CBOR based data that is to be transferred from transport layer to the mobile application. Now, why JSON comes into picture or CBOR comes into picture? And our Android phones, so they also need some data format. They also have some other data format that can be understandable. So whatever data comes over here need to be converted into a specific language so that your device or your application can be understood. So where we use JSON based data, that is a key or value based data. Then it's like IoT application and device manager. It's nothing but what I told, like each device has any number of applications, and like that we can just think of it. Now it comes transport layer. That is, it is basically a we are known to it like any transport mechanism is widely used is TCP or UDP based communication or socket based communication. For any communication, client server communication, we require this a socket communication, so that can be a TCP or else UDP. Any of this communication is required to establish a socket communication or a connection between our IoT application, that is a mobile phone or any device, with our lightweight device, that is RF based device or N device things. now it comes internet layer, that is IP based communication, which is widely used in IoT, internet and network connectivity. As we have been discussing, internet and network connectivity are the major things which plays an important role. So, and this devices or this layer widely supports IPv4, IPv6 based routing. And now it comes up is like physical or the link layer or the network layer. So basically this layer where physical module resides onto specific device. Let's say if we have I'm not sure how many have used a Philips based Hue bulb. Just if when you go to your just in a free time, you can just search Philips based Hue bulb. These are nothing but normal bulbs, but having the ability to get connected. That is, it uses these are in a technical specification. You can just check. It uses Zigbee based modules. Means each bulb is having that. How it comes is like three bulbs, a pair of three bulbs, and one small router comes with the when we buy this device. So how this connectivity works is like it has its own application. Philips Hue application name is there. So that comes into our application layer. It has multiple features. We can change the color, we can dim the color, we can on and off, we can create a scene based on off activities. Then these three bulbs are having Zigbee modules. You can just easily, the company has specified these are Zigbee based bulbs which gets connected to its router, and router has both the physical modules like Wi-Fi as well as Zigbee. So the router gets connected to those three bulbs. It happens, the data transfer happens over there, and that router has the ability to get connected to internet, and from which we can receive the data or we can send the data. So this is how stack resides. It was the real-time example, and this is how it works. The ecosystem, or we can say any solution, this way it works. So now let's just move forward with some real-time application, or what are the key applications. So if we consider IoT into a daily life or Internet of Things in a as a layman, now you are known to the how, what and where. What is this three questions of the IoT? So you will be able to answer like, okay, we can use this technology into smart, that is houses, that we can call it as smart houses. Then the variables which we are already using, which are connected to our mobile phone, to our home, everywhere can be connected. Then we can consider the smart cities. Then let's move forward with the smart grid. Now, at the end of this slide, we'll just exemplify this smart grid concept. Then with the IoT healthcare, that is like wearable is connected to with multiple sensors, like it can measure our heart rate or BP and all multiple other features, which can be connected to, we can connect it to our normal physician, or that is the family physician. And that data can be collected over the cloud, and can be shared to the physician, that in this week what activities were done, what kind of data was there, or what how your body reflected those activities, and that can be analyzed by the MD physician or any our doctor. Then industrial IoT, that is industry 4.0. It's like empowering industrial engineering with sensor softwares, big data analytics to create brilliant machines. That is, huge machines are there. We are empowering them, or we are embedding them on them different sensors, with having an ability to get connected with the internet, with multiple softwares, and having connect ability to get connected with the cloud services, that is for big data analytics. Then comes up it like connected cars. So these days we are very fond of getting used to the MG car, or we can say uh, XUV 700 these days. That is huge buzz these days. So it has multiple connectivity. We can connect. We have an inbuilt feature of GPS, right? Or mobile phone. We can get connected to internet from car itself. Huge or the wide use of infotainment systems, wide screens, and wide sensors. If we are not wearing the safety belt, then it some cars have an ability that it will not start. We have to wear the seat belt. Then it will alert you again and again that it's not seat belt is not wear for whom, for what, for passenger safety. It is a vehicle which is able to optimize its own operation, maintenance, as well as comfort of passengers using onboard sensors and internet connectivity. That is maintenance and operation. It's like it will daily check the engine activity or any this all small modules or small parts will be embedded with onboard sensors, and which will collect, give the data to its hub, and it will communicate and populate the data to the passengers for easy and for the comfort. Then smart retail. So I'm not sure these days. Before few days, there was one video which was very viral. Like if you move, the kid in US was just picking up the grocery items, and his parents got the bill automatically. There were no these days when we go to malls or supermarket, there are multiple billing counters. In future, there will be no billing counters. It will be so these devices or our day-to-day use items will be connected to internet and will automatically populate to our mobile phone application, and we can easily pay the bill. Once we pay the bill, for us, we can move out easily from that supermarket or the store or the retail counter. Now let's discuss smart grid. So what it is, like these days we are used for logistic purpose. We are using fastech based system on highways, express highways or national highways. So the smart grid is nothing but a concept, part of a concept. It's like these days EV vehicles or electronic vehicles are moving. This it has they are picking up the trend, or they are picking up very widely due to increase in petrol and diesel prices and support of the government to promoting the electronic vehicle or EV vehicle. Now, if I own a vehicle, EV vehicle, you own EV vehicle, many people you owns EV vehicle, which is an ability which just to drive 300 kilometer, 400 kilometer. If we have a petrol or diesel car, we have multiple petrol bunks or diesel bunks to reinstall or just have a petrol whenever as and when required. Now if we are connected, that is a battery based car, EV based car, then we need some stations, charging stations that requires, and charging station is like a charging mobile phone. It takes 1 hour, 1.5 hour to charge your full car, which can drive you for 300 kilometers, and that's very time consuming as well. It's very difficult for scalability or integratability. So the concept of smart grid is like where the normal real-time use case scenario is when you are driving on a highway, and if any restaurant comes up, if you want to have some refreshments, you can take that refreshment, you can park that car, and just plug in the charging points into your car. As and when your refreshments are done, you can come back, you can just move out the or unplug the charging plugs, and there is no requirement of payment. It will automatically get detected from its since these charging points will be connected to your bank account or its e-wallet, and then automatically the amount will be debited. So this way smart grid works, and there are multiple more concepts into it, but it's like it will be very early stage to explain you those concepts. This was the basic concept. Smart grid, a future smart grid comprises to use information about the behavior of electricity suppliers and consumers in an automated fashion to improve the efficiency, reliability, and economics of the electricity. So this basically it's used widely used for electrical connectivity or electricity or power connectivity. This concept is widely used for these things. Now, IoT application, this image tells you 1,000 words, we can say. So what it is, let me just brief you out. This is the like technology. So using technology, what we can do, we can harvest energy, that is smart grids concept. Security, yes, this using this technology we have with the expansion of the technology, we are also expanding or we are also improving or evaluating in the security perspective also. If security will be there, then only the people or the human beings can use those things. AR, VR, that is artificial intelligence, virtual reality, machine learning, that is having an ability to learn the human activities and react upon it or act upon it using cloud services. Then computing, that is data analytics, big data analytics, communication and sensors, which we have been using this two words like normal devices. We connect the sensors and having an ability to communicate with each other. That is communication and sensors. Now the applications, what are different uh, verticals of applications? That is manufacturing, that is industry IoT, industry 4.0, and the smart factory, that is converting the heavy duty machines or heavy loaded machines with smart sensors or uh, added things, added embedded software or hardware, and we can convert them into a smartness with a, so the interoperability works very efficiently without any human intervention. Then infrastructure, that is intelligent infrastructure and structural health. So I can just help you with one of the use case. Whenever we see in Vadodara, we have we were having these days Balaji Agora Mall, right? This site was working, is been getting constructed since 2 years or 3 years, maybe. Many huge manpower would be required for such a huge construction, for supervising the things, if whether the labor work has done proper they done their due diligence duties properly or not. Now Internet of Things, using this IoT, we can operate these things in an easy manner. It's like there are multiple devices which have an ability to watch, that is camera surveillance. Based on surveillance, it can act upon it. Like, let's say, if at one site or one edge we have kept the camera, it will define the objects what all are available, what are all there on the object. So if let's say a hammer is uh, kept over there by some labor without any reason, what it will do, it will detect that it is a hammer. It will send the message to the supervisor that this hammer is been kept here without any reason, because work is not going on, and this can damage either somebody, it can harm to somebody if somebody is coming to visit the site, and can have a damage. So what will happen is, like, it is connected to a mobile phone or a mobile devices, and the supervisor can be able to surveillance these things and will be able to drive or will be able to uh, ask to the specific labor to remove this or move this object to the proper place, and it will have a tag whether this task is done or not. So that is how intelligent infrastructure works. Smart logistics, that is nothing but connected cars. We these days, the transport owners who owns multiple more than 15-20 vehicles, they use these things to drive the activities of their drivers as well as vehicles. living smart city, that is nothing but a public based utilities which is totally handled by government bodies, not for the personal use. Healthcare, agriculture, and mobility. Mobility is nothing but mobile devices which are intelligently connected with each other in a smarter and efficient manner. Healthcare is the example which I gave is variables. We can be easily get connected, and our doctor can view the data of any patient or any partially impaired person, and can provide the medications over the internet itself. Agricultural, that is smart monitoring and precision agriculture. We will cover this use case in a real time use case of this agriculture. Now, what this IoT applications or IoT is required to fulfill its ability, as well as we can say a end-to-end solution. There are overall 5 points to be considered. That is, first is the major point, intelligence. Any normal thing we want to convert it into, means we any problem or scenario we want to solve this using IoT technology, we must embed it with an intelligence. Now intelligence can be embedded, but the efficiency or the accuracy of any intelligence is must. Then only we can say it's a proper or accurate solution, and which can be adopted by human beings or any industry or any vertical. It must have a feature of connectivity, that is connecting to internet or connecting to people, connecting to multiple sectors in the same way. Transparency, that is we are exchanging or transferring the data in IoT basically. So it is like exchange of or transfer of data. Then there is a requirement of transparency. What data we will use? If you are using of any personal person's personal data, we need to be that much transparent that what and why this data is getting used. And a flexibility, that is it's not like if I am connected to one variable, I cannot connect my smartphone to other variable. That thing must not be there. I can connect to anything. That is a flexibility. If I want to upgrade my technology into a, let's say, a smart living, that is home, and if I want to move that device out and want to bring up new device, that much flexibility must be there in a IoT application or IoT based ecosystem. So to design or to deploy the problem of using this IoT, means providing a solution using IoT, these 5 points are very major to be considered and to be taken care of in any of the verticals or in any of the scenarios. uh, we can consider it. Now, this is basically I'm just trying to brief you out about how we discuss the stack and the application of agricultural application. So object layer or perspective layer can be our physical or Mac layer. Just try to visualize the IoT stack which I explained you or which I brief you out in before 3-4 slides. And this is how in agricultural domain or a smart monitoring or precision agriculture we can use it. So physical layer or link layer will be having agricultural sensors, that is RF based sensor, GNS modules, that is to track the uh, sensor activity or the sensor locations. Crops health, that is a monitoring health. Livestock, that is the level of seed or the level of water into the soil. Agricultural machines, so there are multiple machineries required for a farmer to farm into his agricultural or day-to-day life. Then these machineries are also connected to internet using our user layer, that is end consumer or anything, that is application layer. Then these things are connected to transport layer. So that is, we sensors have these modules like Bluetooth, Zigbee, RF modules. These things are need to be connected to LAN or WAN, that is global or local network, using Ethernet or Wi-Fi or CAN. This CAN is basically used in automated car, or we can say car-based communication, that is infotainment system, or we can say connected cars. This is widely used. Then this WLAN Ethernet, how, or WiMAX, how this can be connected on a global network. It's like using an existing network, cellular network, that is 4G or 5G. So this is how transport layer works. Now comes up with this is basically a transport as well as a network. The layer above the transport, that is like data transferring, means IP based communication. Here IP will be allocated, and the data transfer can be done in 4G or 5G using specific data format, that is UDP or TCP based communication. Then application layer comes up. There are multiple applications which are designed or which are developed by an user, that is cloud service, cloud storage, cloud computing, cloud. These are cloud based applications, because whereas and when we get this data, we store it onto the cloud, we compute it, or we provide the data aggregation, or we provide this data to different applications. And different applications for end user is like, or for a farmer is planting, gardening, breeding. These are the specific applications. This can be done, or this can be managed using multiple sensors or GNSS, crops or livestock. And at the end, user layer, means this whole application layer will be having multiple applications, like it can control the farm, as well as it, when it using livestock or crops, it can transfer this to system manager or end consumer. It means it can list that this crop I have, you, if you want to, means he or she or a farmer can design its own e-commerce application also. So this can be considered like, from how this ecosystem is designed, from farm, that is from land, from seeding the farm to end, and how it reaches to end user. This is completely an ecosystem, that is agricultural producer or system manager. It's nothing but the any support if required for this connectivity. It's like a system manager, and agricultural producer is himself a farmer. Then these are the three real-time use case. uh it's like told about a grocery store, that is smart retail, that is paying at a grocery store with connected watch. We have a variable, we can easily pay that using just a simple tap. If you We have been seeing that advertisement, PV Sindhu's advertisement in TV, the tap, we tap for you, you tap for us. It is the same. Why our debit cards can be used, that is having NFC, nothing but NFC technology can be used. In the same way, our smart variables also have a NFC. So if we tap it, it can automatically pay via our mobile phone. Paying fuel with a connected car. This is the same, that is smart grids, like plug and play activity, and it will be automatically deducted from the wallet or from the bank account. That is just another scenario. Then it is like paying for eggs through a connected refrigerator, that is in a home automation. These days, if you see, there are multiple uh, smart fridges available in the market that can be connected to a nearby retail store like Reliance Jio's store or anywhere, whenever, as and when required, and it is connected to our mobile phone. So as and when it prompts that there are no eggs available, if you want to have it, need to order. So this, our mobile phone, with our single tap, we can directly order the uh, to the specific application or a specific owner of the store, like Geo Store or Blinkit application or Zepto or anybody, and nearby retailer can provide you the service directly, without, in a seamless manner, and without any intervention, your intervention, or without any disturbance of your day-to-day life. Thank you. That's it. Any queries or questions?
Thank you very much, sir, for the wonderful session. Sir, we are having one question from one of the faculty members.
Yes.
The question is, which kind of sensors we can use, control devices we can use with the IoT?
So it is not like which kind of, there are many multiple sensors. These days we have already have a smart devices. Okay. So those devices comes up with inbuilt RF modules. Okay. So, and that can be controlled, or that can be connected to any, it is not like IoT is like connecting internet only. Connecting internet will be for a global network. But if we want to, like, let's say our smartwatch, that is smart wearable, and mobile phone, we are connected to this, both these devices using Bluetooth. Even though we are connected with the Bluetooth, we get those smartphone messages, that is WhatsApp messages. How? The Bluetooth, because our mobile phone is connected to internet, that is global network. As and when we receive a notification, we receive a message, we get that message to our smartphone or a smart wearable, that is using a gateway of Bluetooth BLE module. And in this way it works. Like if I consider like a small project, like if I want to convert my normal plug into a smart plug, there are multiple embedded boards which are available in the market that has inbuilt Wi-Fi or BLE. We just need to uh, create a software application or develop a software application, and have to just configure it with some hardware connections, and that's normal plug can be converted into a smart plug. I hope I answered your query, means you got some clear point.
Yes, sir, definitely. Okay, sir. So on behalf of Parul University Diploma Studies, I would like to thank Mr. Shreyans sir for delivering such a wonderful session for the student and as well as for the faculty members. Sir, at present we did not have any question which is listed. Once we receive the question, I will mail the questions to you, the common question which is received by the uh, received by
Sure,
us.
sure,
Okay,
sure.
sir. Thank you very much, sir, for your time and cooperation. Thank you very much.
Thank you, thanks a lot for giving me such a beautiful opportunity. Thanks a lot.
Welcome, sir. So we can end this webinar.
Okay, thank you.